All right, let's see. This case, you have a y squared term, so we should write it as x equals everything, and then get it in the format that we are used to. So again, add 34 to the left side, so we have x plus 34. Factor out the -2, so -2 times y squared minus 8y, complete square. So what do you think we should add here? It will be -4 squared. And what is -4 squared going to be? -4 squared is 16. So how much should we add? Should we add 16? No, because look, we have -2 times 16. -2 times 16 is how much? It's -32. So we're actually subtracting. So -32 is what we have to add on both sides so that the equation remains the same. And so now we have x plus 2 equals -2 times y minus 4 squared. Now we are ready to graph the points. So our x coordinate is -2 and our y coordinate is 4. Don't forget how the roles are now switched for x and y because it was y squared, but still the vertex is right there. So that is our vertex. And then this time we're going to plug in y coordinates, so that'll be easier for us to solve for x. Since 4 is a y coordinate for vertex, I plot 2 points below and 2 points above and then sketch the graph. Now in this case, if you look here, they gave you a parabola tool, so you actually don't need all these points, you just need 2 points. You need the vertex. So you're going to take your parabola tool and go to -2, 4. So -2 for x, and y coordinate is 4. Click, drag the parabola in the orientation you want. If it's up, you drag up. If it's down, you go down. If it's right, you go right, and so on. In this case, since the -2 is the coefficient of y squared, we know it opens to the left. So click on the left side and then drag it to one of the coordinates. So we have -4 is our x and y is 3. -4 is our x and y is 3. So click, and there's your points. Make sure that you really understand which is your x coordinate, which is your y coordinate, so you don't make mistakes, because that is one of the common mistakes that people make here. All right, next question. Again, plot points, but remember, we already saw that absolute value is the V shape, and so the vertex, similar to the vertex, x coordinate is going to be what? Our x coordinate is 2, and when x coordinate is 2 and you plug it in here, y coordinate will be 5. So 2, 5 is our vertex. So let's plot that point, 2, 5. Now you want to draw the two rays that make up the absolute value, and then you just draw the graph. So again, this is an exponential function, and so what we have here is asymptote of 0. Since there is no plus or minus here, we know the asymptote stays at 0. The negative means instead of the graph going this way, it's going to be reflected across the x-axis, and since the number a is smaller than 1 because it's 2/3, it's going to go this way. So that's our prediction. You should always have a sense of how the graph is going to look. And now it's just a matter of plugging in these coordinates. So I'm going to let you finish that, and this is how the final graph will look. All right, for number 9, they are giving you the graph of e to the x. They're saying sketch this graph. We already know that x minus 3, so it's shifting 3 to the right. -2 means down 2. So a hand will appear and you just go 1, 2, 3 to the right and 1, 2 down. And that will be your graph. When you are graphing logarithmic functions, remember we need to figure out what our vertical asymptote is. So since we cannot have logarithm of 0, we know that we have to set x plus 4 to 0, which will give us solution x equals -4. So our vertical asymptote is x equals -4. So here's our asymptote, x equals -4. Now, how do you decide what points to plot? Remember, if you're evaluating log of something base 4, this something here needs to be powers of 4, like 4, 1, 1/4, 16, and so on. So in order for the x plus 4 to be 4, we need to plug in x equals 0. Let's say we want x plus 4 equals 1. We need to plug in x equals -3. Okay, now just evaluate. 4 to what power gives you 4? We know it's 1. So this is going to be 1/3 times this value will become 1. And that will make it -8/3. What about this one? 4 to what power gives me 1? 4 to the 0 power will give me 1. So that value is 0, which will give us -3. So plot those points and then connect. All right, so let's rewrite this, which will get our vertex. So our vertex is going to be x is 0 and y is 7. We need to plug in coordinates. Let's plug in 1. So if we plug in x equals 1, this is what we will get. And so let's plot that. So here is our parabola tool. We're going to go vertex is 0, 7, facing downwards, and 1, 6 is the other coordinate. Because it's greater than and not greater equals, we know none of the points in the parabola are our solutions, so we have to make it a dotted graph. And now we have to do a test point. So what point do you want to pick? Say 0, 0. So plug in 0, 0, we'll get 0 is greater than 0 plus 7, which is false. And so that means you're going to have to shade that region. And we've done problems like that before. All right, this next example is similar, except now we have to complete squares. So put the 5 on the other side. Let's factor out the -1 out here. And so you're going to have x squared minus 6x. So we're going to have to add, what do you think? So we have to go -6, half of that is -3. -3 squared is 9. But what we're really adding is -1 times +9 is -9. So we have to do that on the other side as well. So now we're going to have y minus 4 equals -1 times x minus 3 squared. And so now we can sketch the graph of this parabola. We have our vertex, which is 3, 4. So let's plug in another coordinate where we're replacing x with 2. And so that will give us y equals 3. So we grab our parabola tool. It's a parabola going down because -1 is the coefficient of x squared. And then we said our coordinate was 2, 3. So 2, 3. It's greater equals here. And so that means that all points on the parabola are going to satisfy our inequality. Now we just have to shade the region. So let's plug in test point. Let's say 0, 0. So let's plug that in. So we're going to have 0 greater than or equal to, and just plug in 0 in everywhere for x here. So this will be 0 greater or equals -5, which is a true statement. So that means you want to shade where the 0 came from. And so that is your solution. Example, we're asked to graph 3 to the power x minus 3. So this -3 is going to control where our asymptote is going to be. So that's 1, 2, 3. So -3 is our asymptote. And then we know it's 3 to the power x. So we just have to plug in some coordinates now. So g of 0. So replace x with 0. So 3 to the 0 power minus 3. We know that 3 to the power 0 is 1. 1 minus 3 is negative 2. And so we need to go 0, negative 2. We need one more coordinate. So that would be, let's say, g of 1. So that would be 3 to the power 1 minus 3, or 3 minus 3, which is 0. So 1 and 0. And there's your graph. Now we're also asked to find domain and range of this function. So domain is all the x values for which you have a graph, or all x values that you can plug in here. So you can see domain is negative infinity to infinity. Range is all the output that comes out of here. So you can see it will have to be negative 3 to infinity, and negative 3 is not included because we can never get negative 3, because 3 to the x can never be 0. So domain here is going to be negative infinity to infinity, and the range will become negative 3 to infinity. So again, negative infinity to infinity is domain, negative 3 to infinity is your range. So again, to do this next question, we are going to look at this plus 4 will be our asymptote, and then plot points. So horizontal asymptote as y equals 4, and then just plug points like 4 and 3, doesn't matter which points. Remember, e is not a variable but a number. What's the value of e? 2.71. So if you look, 2 times 2.7, so a little over 4, plus 4, so a little over 8. So let's plot that. So you should have some sense of what you're plotting. So you're going to have 2 times e plus 4, and then plot, and then 3 and 6, plot, put the asymptote at 4, and then click, and there's your graph. Again, log x base 2, so x cannot be 0, so x equals 0 is your vertical asymptote, so let's place that. And then we just have to plot points. Remember now, how do you decide what points to plot? Since it's log base 2, you want all powers of 2 here. So let's say 4. So this would be 4 plus log 4 base 2. How do you evaluate log 4 base 2? 2 to what power gives you 4? We know that 2 to the second power gives you 4. So that's why this is 2. Log 4 base 2 is 2, because 2 squared is 4. Similarly, log 2 base 2. 2 to what power gives you 2, which is 1. So you have 4 plus 1, or 5. So those are your coordinates. So let's plot them and then connect. All right, so here, again, x plus 1 cannot be 0, so if you set that to 0, you get x equals negative 1 is your vertical asymptote. And then you just have to plot these points. And again, since it's log base 3, whatever you plug in here has to be powers of 3. So if I want x plus 1 to be 3, then I have to plug in x equals 2 and x equals 8. And so log 3 base 3, 3 to 1 power is 3, so 1 minus 3, which is negative 2. When you plug in 8, 8 plus 1 is 9, and so 9 log base 3 of 9, 3 squared is 9, so that value is 2. 2 minus 3 is negative 1. So let's plot those points, and our asymptote is at negative 1. Make sure it goes through the point that you just plotted. Okay, what about domain? So if you look, there is no graph corresponding to values less than negative 1. Negative 1 is not included because that's your asymptote. So it's negative 1 to infinity, and the range is all the y coordinates. Even though you cannot see this, eventually it will go above. So the range is going to be negative infinity to infinity.